I want you to try something. Picture the Earth. The whole thing. Every ocean, every mountain range, every city, every person who has ever lived. Everything that has ever happened in human history. Every war, every discovery, every moment of joy, or grief, or love, or fear, happened on the surface of that sphere. Now picture the sun sitting next to it. The Earth is a marble. The sun is a beach ball 2 meters across, sitting 200 meters away. Now picture the nearest star to our sun, Proxima Centauri. On that same scale, the marble Earth, the beach ball sun, Proxima Centauri is another beach ball sitting 50,000 kilometers away. We have not left our immediate neighborhood yet. We have not reached the edge of our galaxy. We have not approached another galaxy. We have not begun to describe the observable universe, and already the numbers have stopped meaning anything. That is the problem with the universe. It is not just large. It is large in a way that human minds were never built to process. And the deeper you go into the actual numbers, the more completely language and intuition fail you. So let's go deeper. The fastest thing in the universe is light. Nothing moves faster. Nothing can. Light travels at approximately 300,000 kilometers per second. In 1 second, light could travel around the entire Earth 7.5 times. In 8 minutes, it crosses the distance between the Earth and the Sun, 150 million kilometers. We use light as our ruler for measuring cosmic distances. 1 light year is the distance light travels in a single year, approximately 9.46 trillion kilometers. If you drove a car at highway speed, 100 kilometers per hour, it would take you approximately 100 years to reach the Sun. To reach the nearest star at the same speed would take you 45 million years. 1 light year. 45 million years of driving. That is the scale of the gap between our Sun and the nearest star. The Milky Way, our galaxy, is approximately 100,000 light years across. At highway speed, crossing it would take 4.5 billion years. That is longer than the Earth has existed. And the Milky Way is not a large galaxy. It is average, medium-sized. There are galaxies in the universe that are 60 times larger. We are still inside our own galaxy. We have not left yet. And the numbers are already so large that every unit of measurement we have invented has ceased to be useful. The Milky Way contains somewhere between 100 and 400 billion stars. Read that again. Between 100 and 400 billion stars. We do not know the exact number. The uncertainty alone spans hundreds of billions of individual suns. Our galaxy is so large that we cannot count what is inside it. Here is where the scale starts to become genuinely difficult to hold in your mind. The Milky Way is not alone. It belongs to a collection of galaxies called the Local Group, approximately 54 galaxies bound together by gravity, spread across a region of space about 10 million light-years across. The Local Group is itself a small part of the Virgo supercluster, a collection of galaxy groups spanning approximately 110 million light-years. And the Virgo supercluster is one small tendril of a structure called Laniakea, a supercluster of galaxies containing approximately 100,000 galaxies, spanning 520 million light-years, with a total mass roughly equivalent to 100 million billion times the mass of our Sun. Laniakea was only mapped for the first time in 2014. We did not know it existed as a coherent structure until 11 years ago. The supercluster that contains our galaxy, our local group, and 100,000 other galaxies was invisible to us until 2014. And Laniakea is one of millions of similar structures in the observable universe. We are a pale blue dot inside a solar system, inside a galaxy, inside a local group, inside a supercluster, inside a cosmic web of structures so vast that the entire history of human civilization is not long enough to have sent a light signal from one end to the other. Here is the number. The observable universe, the portion of the universe we can theoretically see, limited only by how far light has had time to travel since the Big Bang, contains an estimated 2 trillion galaxies. Not 2 trillion stars, 2 trillion galaxies. Each galaxy containing anywhere from millions to hundreds of billions of stars. Each star potentially hosting planets. Each planet potentially hosting conditions for something. The total number of stars in the observable universe is estimated at approximately 1 septillion. That is a 1 followed by 24 zeros. More stars than there are grains of sand on every beach and desert on Earth, by a factor of roughly 10,000. Every grain of sand. Every sandstone cliff and riverbed and ocean floor. Every particle of sand on every continent. And then multiply that by 10,000. That is how many stars exist in the portion of the universe we can observe. And the observable universe is not the whole universe. It is just the part we can see. The actual universe, the total extent of everything that exists, could be infinite. Current cosmological models suggest the universe extends far beyond what we can observe, possibly without limit. We do not know where it ends. We do not know if it ends. In 1995, astronomers pointed the Hubble Space Telescope at a patch of sky that appeared completely empty. What came back changed our understanding of the universe permanently. In that tiny patch of apparently empty sky, a region so small that it would be covered by a grain of sand held at arm's length, the Hubble telescope found approximately 3,000 galaxies, each one containing billions of stars, each one hundreds of millions of light years away. That image is called the Hubble Deep Field, and it revealed that every point of apparently empty darkness in the night sky is not empty. It is full of galaxies too distant and too faint for the naked eye to detect. The darkness is not absence, it is distance. But here's the detail that I find most difficult to process. The light from those galaxies in the Hubble Deep Field left them billions of years ago. What we are seeing when we look at those images is not what those galaxies look like now. It is what they looked like billions of years in the past. We are not looking across space. We are looking back through time. The universe is so large that light takes billions of years to cross it, which means seeing the universe and seeing the past are the same thing. Every image of a distant galaxy is a fossil, a record of something that happened unimaginably long before the Earth existed. From 2 trillion galaxies and 1 septillion stars and a universe that may be infinite in extent. Back to here. You are sitting on the surface of a rocky planet, orbiting one average star among 400 billion stars in one average galaxy among 2 trillion galaxies in the observable portion of a universe whose total size is unknown. The distance from your feet to the center of the Earth is about 6,000 kilometers. The distance to the edge of the observable universe is 46 billion light years. The ratio of those two numbers is so extreme it cannot be expressed in any units that carry meaning. And yet here's the thing that the scale of the universe does not tell you. In 2 trillion galaxies containing 1 septillion stars, we have found exactly one place where something looks back at the sky and wonders how large it is. We do not know if that is unusual or common. We do not know if the universe is full of things wondering about their own scale, or whether this one pale blue dot is the only place in 46 billion light years of space where something is capable of being amazed. That question, whether wonder itself is rare or abundant in the universe, may be the most important question our species has ever asked, and we do not have the answer. Here is what I want you to take from this. The universe is not large in a way that makes you feel small and irrelevant. It is large in a way that makes what happens here, on this specific rock, at this specific moment, genuinely extraordinary. Because the universe had 13.8 billion years and 2 trillion galaxies to produce something capable of understanding its own scale. And as far as we know, it only managed it once. Go outside tonight if you can. Find somewhere dark enough to see the Milky Way. Look up. Every point of light you can see is inside our galaxy. The faint smear of the Milky Way contains 400 billion stars. And beyond every dark gap between those points of light, there are galaxies beyond counting, stretching in every direction, further than light has had time to show us.